Welcome to ChemE USM MATLAB tutorial channel. Today, we're going to create a MATLAB program that calculates the benzene mole fraction in a batch distillation process. Let's get started. First, let's understand what we're trying to achieve. Consider a system for heating a liquid benzene/toluene solution to distill a pure benzene vapor. A particular batch distillation unit is charged initially with 100 moles of a 60% mole benzene/40% mole toluene mixture. Let L, mole, be the amount of liquid remaining in the still, and let X, mole B/mole, be the benzene mole fraction in the remaining liquid. Conservation of mass for benzene and toluene can be applied to derive the following relation. The equation is given there. Determine what mole fraction of benzene remains when L equals 70. Note that it is difficult to solve this equation directly for X. Use a plot of X versus L to solve the problem. So, this question wants us to find the benzene mole fraction when there are 70 moles of liquid remaining in the still. We start with the programming style that we have learnt in the first video. Next, we set up our input and output variables. L is the amount of liquid remaining in the still, and X is the benzene mole fraction in the remaining liquid. Remember, L is in moles, and X is a ratio, mole B/mole. Now, we define the relationship between L and X using this parameter equation. It's a bit complex, but it's taken from the equation in the question. This equation will help us calculate L for different values of X. Let's move on to the calculations. We create an array X that ranges from 0 to 1 with an increment of 0.001. This represents all possible mole fractions from pure toluene to pure benzene. Then, we calculate L for each X using our parameter equation. If you notice, there is a dot before the multiply and power symbols. It is the method when we want to multiply and power an array. Finally, for the output section, we plot our results. We use the plot function to create a graph of L versus X, add grid lines for clarity, and label our axes. We also set the x-axis limits from 0 to 100 to focus on the relevant range because, as stated in the question, L start with 100 moles and decrease over time. It means that L is greater than 0 but lesser than 100. After done, let's run the code. And there you have it. You've just created a MATLAB program to calculate the benzene mole fraction in a batch distillation process. Run the script, and you'll see a beautiful plot that shows the relationship between L and X. So to know what is X value when L equals 70, just click the point on the graph. And there you have it. If you have any question regarding MATLAB, feel free to scan the QR code and ask me. I will try my best to assist you. Thanks for watching, and